Okay, so we're going to be starting a new section today called polar coordinates. Okay, so before we get to polar coordinates, we're going to do a quick recap on what coordinates are. So everyone should be familiar with Cartesian coordinates. So we will look at that a bit more generally and then work our way to polar coordinates, converting between Cartesian and polar, and then sketching polar coordinate graphs. Okay, so we know how to do graphs in Cartesian coordinates, y is a function of x. We're going to look at graphs in these polar coordinates. Okay, but before we get to that, what is a coordinate system? So a coordinate system is a method to label points in some space. So we're just going to be working in 2D. However, this extends to like 3D, for example. You can have X, Y, Z, but we're just going to be working in 2D spaces. So a coordinate system is a method to label points in a space. Okay, so let's say we have two-dimensional space like the page. If we have some point over here, let's call it P, we want to label where it is. Now in Cartesian coordinates, what we do is we pick some origin point, call it O. We set up orthogonal axes like so. We call the one X, we call the other Y, and then with reference to that origin, we can measure how far away we are along X, how far we are along Y, and then that intersection bit there, that gives us the Cartesian point XY. Okay, now this is a pretty simple coordinate system to work with. It works perfectly fine. However, it's not the only coordinate system available to us. We can choose something else. For example, we can say that the x-axis stays where it is. We're going to leave it like that. But the y-axis doesn't have to be orthogonal. It can be at some angle. So let's say we've got the origin here, and let's say that the y-axis is like this. Okay. So if we were to draw in the grid, instead of being little squares on the Cartesian axis, Cartesian system, it's going to be something like this. Okay, we have diagonal lines parallel to y, and we've got these horizontal lines parallel to x. And then we can have some point here, P. Okay, and this will have a different coordinate to the other one. So we see that the y-axis is angled, so it's going to give us a different number, but it's the same point. So we see here point P can be labeled like this, using this coordinate system. We can use another coordinate system and label the same point. Okay, so this is something else that we can use. The one that we're going to be interested in is the so-called polar coordinates. Okay, so polar coordinates. Again, we need some system of two different lines to get the point. Since it's 2D, we're going to have two systems of lines. Like we had here, we had the horizontal lines and we had the diagonal lines. Okay, for this system, over here again, we've got horizontal lines and vertical lines. For polar coordinates, it's a bit different. We again have an origin, let's call it O. But now, instead of having orthogonal lines, we're going to have radial lines, so like this. But then you can imagine in all possible radial directions, we have lines going out. Okay, so this measures distance from the origin out to some point. So if we have, for example, some point here, let's call it P, it's going to be a distance R away from the origin. Okay, so it's measuring the distance from the point to this origin that we specified. And you can have any point, so let's say Q over here. Again, this line, let's put it R, that's the distance from our origin to that point. Okay, so that's the one part of the coordinate. The other part of the coordinate is this angle that the line makes with the horizontal. So we call that theta. If we know the distance from the origin and we know the angle from the horizontal, that gives us the coordinate for the point. So for any angle that we go around, for any radial distance, we can use that to label the point. Yeah. And then typically we draw it like this. Okay. So you can imagine this as concentric circles. So each circle corresponds to a different radius value or a different distance to the origin. So this first circle that might have a radius of 1, the second circle that has a radius of 2, the third one that has a radius of 3. So we see that point P is just a bit more than 3 away from the origin. And then we can also look at this angle. So those make up the radial lines going all the way around, like a clock goes all the way around. So here, maybe this angle over here, maybe that's something like pi over 6, or 30 degrees. Okay. So it's just a different way of labeling it. Instead of having horizontal distance and vertical distance to give us x and y, we now have radial distance and angle from the horizontal. Okay, it's just a different way of writing down these points. Okay, anybody confused with that? Okay, it's just a different way of labeling the point. So instead of using horizontal distance and vertical distance, we're now using radial distance and angle from the horizontal. Okay, any questions on that? Yeah? Sorry? Okay, so we've got this point P. We want to describe where that point is. So since this is two-dimensional, we need 2 bits of information. If this was Cartesian, we would use x and y. Okay, so the way that we describe P is by the distance to the origin. Okay, so there's your point P. We pick the origin wherever that is. The distance to the origin, we call that r, like the radius. Okay, but all the points on that circle, so you can see the circle here, the circle going around here, all of these points are the same distance. Okay, but we're interested in just P. We're not interested in all the points. So how do we distinguish between point P and other points on the circle? We look at the angle. So this angle tells us how far around the circle we are. If the angle is 0, it means we're on the far right there. Okay, at the 0. If the angle is pi over 2, it means we're at the top, because that's where pi over 2 is. If the angle is pi, it means we're on the left. If it's 3 pi over 2, we're at the bottom. Okay, so this angle tells us where on the circle we are. So the radius, that tells us which circle we're on. The angle, that tells us where on the circle we're on. Okay, is that all right? Okay, any other questions on that? Yes? Yeah, so this origin, that's the same as like your Cartesian origin. So if you have your y and x, that middle point. Yeah, no, it's still the origin. Yeah. Yeah, so we're going to start here, so positive x-axis, that will be 0, and then it goes around. Oh, we're going to get to that now. Okay, yeah, so the angle there, that's 0, and then we see we go counterclockwise around, that's the convention. So here, point P, that's at pi over 6, then we're going to end up at pi over 2, pi, 3 pi over 2, and then back at 2 pi. Okay. Okay, so let's go on to that converting. So since this is just a way of labeling the points, we can go back and forth between different labels. Okay, so the point P, that doesn't care about which coordinate system we use. We can use polar coordinates, we can use Cartesian, the point is still the same. So what that means is there must be some way of going between the coordinate systems. Okay, so let's look at the two ones that we know now. So Cartesian, and then we want to go back and forth between that and polar. Okay, so we're going to draw it on the same plane here. We've got this point P. Okay, and we know that we can write it in terms of Cartesian if we want to. We can also write it in terms of polar if we want to. Okay, so what is this point in Cartesian? Well, here is x over there, and then over here is y. We can look at this bit. Sorry. We can look here, and we can look there. So we can have a y part, we can have an x part, and that gives us in Cartesian. So this distance along here, we call that x. That's the horizontal distance. This distance here, we can call y, that's the vertical, and that's what Cartesian is all about. You've got the horizontal part, you've got the vertical part, that's how you can describe the point. But we know now that there's another way. We can use this radius, r, and we can use the angle from the horizontal. So this angle, theta. Okay, and remember that this is at right angles. So from this diagram, where we've overlapped the two ways of thinking, we can see that there's a way to go from one to the other, because the radius and the angle from the polar coordinate form and the x and the y from the Cartesian form, if you put that together, we get a right angle triangle. And we know that with a right angle triangle, we can use trig to find the lengths of the sides. Okay, so let's just redraw that triangle. Okay, at the bottom we had x. On the side we have y. The hypotenuse is r. And the angle is theta. Okay, so I've just took this diagram here and redrew the triangle. But now from this triangle, we can see that there's a way to go back and forth between the two sets of variables. Okay, so how do we find x in terms of r and theta? Okay, we can solve for x in terms of r and theta. We can solve for y in terms of r and theta. We can also go the other way around. Okay, so let's start off with, given polar, how do we find Cartesian? So polar, that's r and theta. We want to convert to Cartesian, which is x and y. Okay, we want to find how to do that. But we can see, we can just use trig. So if we want to find x, that's going to be r cos theta. Yeah, we know what r is, we know what theta is. If we use this equation, we can find x. Okay, how do we find y? That's going to be r sin theta. Sorry, y is r sin theta. So, given the radius, given the angle, we can find x and y. Okay, so that's from polar to Cartesian. But remember, we can go both ways with this. We can also go from Cartesian to polar. That's r and theta. And again, we can use the triangle. Now we imagine we don't know r and theta, but we do know x and y. How do we go back and forth? Well, to find r, we know the other two sides of the triangle. It's a right angle triangle, we can use Pythag. So r squared is going to be x squared plus y squared. We can take the root and we can get r. Okay, we know x, we know y, we can find r. What about theta? Well, we know x, we know y, we don't know theta, but we know the trig ratio that involves x and y. That's tan. Tan theta is y over x. Okay. So if tan theta is y over x, remember we want theta theta will just be inverse tan, or arctan, of y over x. Okay. So that's how we go back and forth between the two. We know how to go from polar to Cartesian. We've derived that. We know how to go from Cartesian to polar. We've derived that. Which means, given any side, we can get to the other one. Okay. Are there any questions about that? Okay. Any questions about how we got to this point? Okay. Let's look at some examples. Okay, so let's say we've got the following Cartesian points. Okay, so we've got two Cartesian points. The first one is 0, 1, and the other one is 2, 2. Okay, just some easy examples. This is in Cartesian. What will it be in terms of polar? So if we want to go to polar, 0, 1. That means x is 0, y is 1. So you can either use the formulae, or you can draw a picture. So let's try draw a picture for this one. So x is 0, y is 1. That means the point is over there. Okay. Now, given this information, we want to find the radius, and we want to find the angle. Let's find the radius. That is the distance from the point to the origin. But since it's at 0, 1, we can just use the distance formula. We know that this distance is 1. So that means the radius is 1. So for this first example, we know that the radius is 1. So let's put r equals 1. What about the angle? That's the angle from the horizontal. So this angle here is 90 degrees, or pi over 2. So we can put theta is pi over 2. Okay, so that's how we convert like that. Let's look at the second one. Again, we can draw a picture. So 2, 2, that's going to be somewhere here. Okay, what's the radius? Well, that's the distance to the origin. That's this distance here. So x is 2, y is 2. We know that r is going to be the square root of 2 squared plus 2 squared. So that's 4 plus 4, or root 8. Okay, you can simplify that if you want, but root 8 is fine. Okay, so that's the radius. We know is root 8, so we can put r equals root 8. What about the angle? So we can complete the triangle. We want the angle, that side's 2, that side's 2, this side's root 8. We can do a bit of trig to find the angle, and we'll see that it's pi over 4. All right, that's like your 1, 1, root 2 triangle. So theta is pi over 4. Okay. Anyone confused with that? Okay. Next example, let's go from polar to Cartesian. Okay, so we've got the two polar coordinates. It's easy to identify because that second entry is going to be some angle. Okay, so let's convert this into Cartesian. So for the first one, we've got the radius, or the distance, is 3. The angle is pi over 6. We know how to go back and forth. The x part will be 3 cos pi over 6. The y part will be 3 sine pi over 6. Okay, so this will be 3 root 3 over 2 and 3 over 2. So that's in Cartesian form. That's for the first one. And then for the second one, the distance, or the radius, is 2. The angle's pi. So it's going to be 2 cos pi and 2 sine pi. So that's going to be minus 2 and 0. So that's the Cartesian form. Okay, any questions on that? Okay, so that is how we convert between polar and Cartesian. So if you're ever stuck, just remember what these formulae were. If you forget the formulae, just remember the triangle, and then you should be able to work from there. Okay, so either memorize the formulae and you can use it like that, or if you forget any of that, just redraw the triangle, and that will help you to go back and forth. Yes? Sorry? Second. Where is that? The Cartesian. Yeah, -2, 0. Start again with that one. Okay, so if we just go here, we're looking at this one. So the radius is 2, the angle is pi. So the x part, I'll just do it on the side here. So x is r cos theta. So x will be 2 cos pi. Now pi, if you look at the cos graph at pi, it's going to be -1. So we have 2 times -1, so that's -2. Let's put that 2 times -1, so that's -2. Okay, so that's for the x part. For the y part, we have y is r sine theta. So y, again, r is 2. We've given that there. Sine pi. If you look at the sine graph, it goes up, passes through 0, and then goes back to 0. In the middle there at pi, it's 0. So if you just look at the, so it goes up, down, and then back up. So here, at pi, it's going to be 0, so y is 0. So we get -2 and 0. Okay. Any other questions on that? Okay. So all of this is pretty simple. You just need to remember how to go back and forth, and then you can convert. The more difficult part is the sketching of graphs. So in Cartesian, we've all grown up with that. We know how to sketch parabolas and so on. That's given. Y is a function of x. Okay, we're quite familiar with that. Sketching in polar form, that's a bit more complicated. Okay, so it takes quite a bit of practice to try to visualize what's going on. So to start off with, we're going to do a little working on the side, and then we're going to draw a bunch of dots, and then just connect the dots. Okay, it makes it a bit simpler. But as you do more examples, you'll develop some intuition about what this should look like. Okay, like if I say y equals x squared, you can imagine what that looks like. If I say r equals 1 plus cos theta, that's a bit more difficult to imagine. Okay, but as you go through the examples, you'll be able to visualize it. Okay, so let's start in the first one. R is equal to 2 cos, let's start off with sine, 2 sine theta. So the way you need to think of this is instead of y as a function of x, we now have r as a function of theta. Okay, so in fact we could write this as r of theta, but usually it's just written r. Okay, like we have y equals x squared. Okay, we don't write y of x, we just write y. Same thing here. Okay, now we're not going to sketch this on the Cartesian axes because it's in polar form. We need to sketch it in polar axes. So we're going to have distances and we're going to have angles. Okay, it looks a bit weird at first, but you'll get the idea. Okay, so we start off with this. Okay, so this looks like Cartesian, but it's not. What we're drawing here is the origin, and then those are our radial lines at different angles. So 0, pi over 2, pi, 3 pi over 2. Okay, so please don't draw x and y. This is polar form. Instead of x and y, we have the angles. Okay, you could draw more lines for the intermediate angles, but we'll see that this is all right. Okay, so that's the first step. We draw in some special angles to guide the sketching. Now, what we need to do is find out what the radius will be, or what the distance will be at each of these angles. Okay, so I'm just going to do a rough sketch of something here. So let's say our final shape looks like this. At each angle, we're going to have a corresponding distance. So for each angle going around the clock, we're going to have a distance. We're going to plot a point at that distance and then connect the dots. We're going to end up with something like this. Okay, so that's the way to think about this. We increase the angle going around, we see what the distance will be, we put a dot there, and then we end up connecting the dots. Okay, so what's this going to look like? Well, let's just do a little sketch of what the distances will be. So we have r and theta, 2 sine theta, so that's going to be something like this, where the highest point is 2, and the lowest point is -2. And then some special angles to help us. We know we have 0, we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so there's more angles in between, but we're just going to stick with these. Okay, at 0, the radius is 0. So that just means we start at the origin. Okay, so I'll put a white dot there, that's our starting point. So that corresponds to the starting point over there. Let's do the next points in pink. So here at pi over 2, we see that the radius is 2. So that point needs to be 2 away from the origin at pi over 2. So that's going to be over here. Okay, let's do the third point in green. That's going to be pi. Okay, that's also 0. So we know that when we go all the way around the top part, we should get back to the origin. Okay, and then I'll show you what happens when the radius goes negative, sorry. Okay, so let's try to connect the points. So now, while we're drawing the graph on the left here, just keep track of what we have on the right. So, when the angle goes from 0 to pi over 2, we see that the distance starts at 0 and goes up to 2. Okay, so just keep that in mind. So the radius is going to increase until we get to 2 as the angle goes from 0 to pi over 2. And it's going to look something like this. Okay, so as the angle went from 0 to pi over 2, the distance started from 0. We see here the distance increases as we go along, and eventually the distance goes to 2. Okay, does everyone see that? Okay, so imagine you start horizontally, you go up until you're vertically, and then that distance increases all the way. So from horizontal, the distance is 0, so you start where you are. As you go up to vertical, the distance increases to 2. So you end up with this arc. Okay, for this next part, from pi over 2, so we're looking at the vertical point there, down to pi, the distance is decreasing. So the distance starts out at 2. As the angle increases to pi, the distance gets smaller and smaller and smaller. So we're going to start here. The distance is still 2. And then the distance is going to get smaller and smaller and smaller as the angle approaches pi. And then we end up back at the origin. So here, if you look here at this angle, as I go closer to pi, we see that these arrows get smaller and smaller. So the distance gets smaller and smaller. Okay, and then eventually, when we're fully at pi, the distance is 0, so we're back at the origin. Okay. So please try to keep this in mind. So just imagine the point going, so for the first half, we know that the point needs to go from the origin to that pink point. Okay, and the distance must increase all the way until we get there. Okay, but the angle's also changing, so we end up with this arc shape. Okay. Okay, so that finishes from 0 to pi. What happens from pi to 2 pi? Now the radius here or the distance, is negative. Now we can't have a negative distance, so what this means is that as the angle increases, instead of the radius or the distance going this way, we flip it 180 and we draw it the other way. Okay. So for here, it just draws back over itself, so we just end up with a double circle. Okay, but of course you don't need to draw a double circle because it goes over itself. Okay, so just draw it once like that. Okay, but we'll see in the last example what happens when the radius goes negative. We need to increase the angle as normal, but instead of drawing the point going out in the positive direction, we flip over and draw it in the negative direction. Okay, but we'll see that later. It's a bit too complicated. Okay, so let's look at another example. R equals 2 cos theta. Okay, so very similar to sine, it's just going to be a bit shifted. Okay, so same thing as before. We draw in our 4 special angles to help us. So those are 0, pi over 2, pi, 3 pi over 2, and then we end up back at 2 pi. Okay, so when you're doing this for homework, please fill in some more angles. So maybe 30 degrees, 60 degrees, 120, draw in those lines just to help you out. Okay, but I don't want this getting too complicated, so please do that for your tutorials and your homework. Okay, same as before, on the side, we're going to draw a little picture of this graph of r versus theta, and we're going to use that as a guide. So, what does 2 cos theta look like? It's very similar to cos theta, but it's just stretched. So it's going to look something like this. So that's 2, and that's minus 2. Okay, so exactly the same shape. It's just the maximum and the minimum a bit stretched there. Okay, so now we can see when the angle is 0, the radius is 2. So now, before we started at the origin, now we're going to start 2 away from the origin. But the angle is 0, so we're along here, and we're a distance 2 away from the origin. Okay, so we'll put that in white over there, so that's this point over there. Okay, let's put the next point in pink. So that's going to be at pi over 2. We know that cos goes to 0 at pi over 2. So that's going to have to be over here. Okay, so at pi over 2, we're looking at the vertical line, but the distance is 0, which means we're at the origin. So let's try put in that intermediate arc. Okay, so from angle 0 to angle pi over 2, so from going horizontally to going vertically, the distance starts out at 2 and needs to end at 0. So we start out at distance 2, we need to get to 0, but remember the angle's increasing the entire time. So it's going to look something like this. Okay. So we see that as the angle increases, let's put in some intermediate lines. So there, 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 there. So we can see the arrows. Those correspond to the different angles. So for the angle 0, we're out at 2, and then these arrows get smaller and smaller until at 90 degrees or pi over 2, the arrow is 0, so we're back at the origin. Okay, very similar to what we did before, but just a different starting off point. Okay, everyone all right with that? Same type of arc as before. So we start off at maximum distance, the angle is constantly increasing, so from here to here it's constantly, the angle is increasing, but the distance is getting smaller. So the arc needs to start off out at a maximum distance and end at the origin. Okay, so that's from the white dot to the pink dot. Let's go from the pink dot to the green dot at pi. So now we can see that the distance goes negative. So we need to deal with that. So we're at pi over 2. We want to go from here to here. Remember, we're constantly going counterclockwise around the circle. Okay. Now the distance is 0, and the distance goes down, so it increases, but the other way, to -2. So what would this look like if this radius was positive? We would start out at 0, and then from pi over 2 to pi, it would have to increase going towards 2. But since we're in that negative part, we're not going to draw it in that second quadrant. We're going to flip 180 and draw it in the fourth quadrant. That's what we do when the radius or the distance is negative. We flip 180 and draw in the other quadrant. If the radius was negative in this first quadrant, we would flip 180 and draw it in the third quadrant. If we're in the second quadrant and the radius is negative, we flip over and draw in the third. The fourth one over here. Okay. So whenever the radius is negative, so here from the pink dot to the green dot, we need to flip over 180 and draw in the other quadrant. Okay, that's just one of the rules that we have to follow. Okay, so with that in mind, we start off with the distance being 0. The distance then needs to increase out to 2. But we're not drawing in the second quadrant there. We're going to flip over and draw in the other one. So let's start. We start off with the distance being 0. Again, the angle increases, and the distance must also increase. So let's do that. The angle is going to increase, and the distance is also going to increase. And we end up over there. Why do we end up over there? Because this was 2 away from the origin, like when we started. Okay, so again, let's put in those arrows just to see. So here the arrows are very short because the distance is small, and then we see that the arrows get bigger and bigger as we go out. Okay, and then that very last one, that's going to be an arrow going horizontal with a length of 2. Okay, if you need to draw in intermediate points, please do that. You can make a little table on the side with as many angle values as you want, and then you can fill in the dots. Okay, but I don't want to do too much here. That will confuse you. Okay, and we're back to where we started there. And then notice, from pi to 3 pi over 2, we have the radius going from 2. Okay, don't worry about the negative. The negative just means we're drawing in another quadrant. The distance stays the same. So we have a distance 2, and then going to a distance 0. But that's what we started with. Remember, from 0 to pi over 2, it was a distance 2 going down to a distance 0. It's the same behavior. So we just repeat that. So from pi to 2 pi, the shape is going to be drawn again. So we end up drawing it over again. Okay, like we had here. So we see that from pi to 2 pi, we're drawing the same shape again, but just in the other quadrant. Okay, so it looks exactly the same like that. Yeah.
In the first drawing, y is 2 in the y-axis, and in the second drawing, y is on the x-axis.
Yeah, that's right.
I mean, like, why is it?
So here, this bit here is 2. Okay, because we've got the 2 there. That is the maximum that this function takes. So we know that sine goes between -2 and 2, but we're not interested in that negative part because that just means flip over. So since the sine has a maximum here at 2, that means the furthest point we go out is also 2. Okay, so here the furthest point out is vertically at 2 because sine has a maximum at pi over 2. Over here, we've got a maximum at 0 because cos has a maximum at 0. Okay, so that gives you an idea of what these should look like. Okay, so again, a little bit more complicated because of that negative radius, but not so bad. Okay, last one for today. R is equal to 1 plus cos theta. Okay, so it won't get any more complicated than this. Okay, so if you can draw these previous ones with different coefficients, or maybe with the minus sign or something like that, you should be fine. This one here, that's as most complicated as you'll get. Okay, so maybe something like 2 plus cos theta, or 1 plus 2 cos theta, but nothing more than that. Okay, same thing as before. We draw in our lines to help us. Please put more if you need, but this will just be for 0, pi over 2, pi, 3 pi over 2, and then back at 2 pi. Okay, if you want to put in more lines, please do that. And then our little help on the side here. So 1 plus cos theta. We know what cos theta looks like. It has a minimum at -1. Since we're adding 1, we're going to shift everything up. So it's all going to be up like that. Okay, so same as we had before with this picture, but just shift it up. Okay, so this will be at 2, that will be at 0, and then we've got this line in the middle here at 1. Okay, so again, let's see where we start. At 0, 2. So similar to what we had before, we're going to be along this horizontal axis at 2. That's our starting point. Now from there to pi over 2, remember pi over 2 is over here, we're going to go from a distance of 2 to a distance of 1. So if that was 2, maybe 1 is over here. Let's draw that in pink. So we're over here. So we want to end up over there at a distance 1. Now the angle is increasing all the way, but the distance is going from 2 down to 1. So again, the angle is increasing the whole time, and we end up at 1. Okay, so it doesn't have to be super neat, but just show that we're going from a distance of 2 to a distance of 1. Okay, now from the pink dot, let's go to the green dot at pi. So we're going from a distance of 1 to a distance of 0. Now we've done that twice already, so you should have an idea of what to do. We're at a distance of 1. We want to end up at the green dot at the origin, and the angle is always increasing. So we're going to have an arc going from the pink dot to the green dot. So it's going to look something like that. Okay, very similar to what we had before. If we're going from a bigger distance to a smaller distance, we're going to have an arc going down to that point. Okay, so that's the green dot. Let's get another color, red. So we've got a red dot over there. That's going to be at 3 pi over 2, so that's this line going down. That has a distance of 1. Okay, just looking at the graph. So let's put the red dot over there. So we're going from the green dot to the red dot. The distance starts off at 0, and the distance increases to 1. So as we're going along, the distance needs to get bigger and bigger until we end up at the red dot. So we're going to have a very similar thing to what we had before. The distance is going to get bigger and bigger and bigger, and we're going to end up at the red dot. Okay. It's all about just connecting the dots. So from the green dot to the red dot, the distance is increasing. So we start at the origin, the distance gets bigger and bigger until we end up at the red dot. Okay, so let me just zoom in here and put in the arrows. I think that might help. So we started there, and then this distance gets bigger and bigger until we're at the red dot. Okay, and those arrows are constantly changing the angle. Okay, last bit, from the red dot back up to the top. Let's put the white dot over there. So from the red dot, that has a distance of 1 away, to the white dot, that's a distance of 2 away. So we've got the red dot at the bottom, we've got the white dots on the right, we need to connect them. So we just connect them. It looks something like that. Okay, so again, it is quite complicated, but with enough practice, you can get the hang of what it looks like. Okay, and then this shape here, if you're going to be looking at this online for more problems or more explanations, this is called a cardioid. Oops. Okay, so like cardio for your heart because it makes a heart shape. Okay, so if you're going to look this up online, look up cardioid and you'll see some pictures like this. Okay, any questions on this? Okay, so just an announcement about the tutorial test on Thursday. That will be on the polar coordinates. So there will be a couple questions on going from Cartesian to polar, like we had here, polar to Cartesian, and then the last question will be a very simple sketch like this. Okay, and then in the tutorials, I think I put 3 sketches, but then there's more there available as well. Okay, if you want me to check it, please just email me or show me your work in the tutorial. Okay, I can check. But the assigned homework is just a few of these. Okay. So I will post this YouTube video, you know where to find that. Also, if you want to look for more stuff on this, my videos from Math196 on polar coordinates, that's also available. Okay, so you'll have the videos from the Math196 playlist and from this one. Okay.